1691 maximum height by stacking cuboids. Given n cuboids where the dimension of the cuboid is going to be the width, the length, and the height, and start from index 0, choose a subset of cuboids. So we need to choose a subset. When it's a subset, it means we don't have to have all the boxes all together, right? It says a subset of cuboids and place them on each other. You can place cuboid I on cuboid J if the width and the length and the height of that cuboid I is smaller than J. So all these conditions are going to be true, and it should be smaller than or equal. You can rearrange any cuboid's dimensions by rotating it to put it on another cuboid. Return the maximum height of the stacked cuboids. So as you can see in this example, so the subset is going to be all three boxes because it's possible to put them on top of each other, and as you see, all the width and length and height of each box on top of the other box is going to be smaller than the other box. In the second example, you see there is no way to put this box on top of another box, this box, because we don't have anything in this which is smaller than 3, so we cannot put this on top of this. And in here, the 76 is going to be bigger than all of this, so it's impossible to put this one on top of this one. So as we are going to return a subset of cuboids, we choose this one. The reason is because this has the biggest number, and we are going to return that as a result. And for this one, because all the boxes are the same size and it can be smaller than or equal, so what we are going to do, we are going to choose the biggest number, the largest number that we have here, multiply that by 6, which is the number of boxes we have, and we are going to return it as a result. So let's see how we can solve this problem. To solve this problem, what I'm going to do, I'm going to sort every single box from decreasingly, like ascendingly. What I mean by that, the first thing, I'm going to sort each box ascendingly, right? Which is going to be from the smallest to largest dimension, right? And what I'm going to do after, I'm going to sort the boxes. I'm going to sort the boxes descendingly, so it's going to be from the largest box to the smallest box, right? And then what I'm going to do, I'm going to use dynamic programming here. Why am I going to use dynamic programming? So as you can see, we can return a subset of these cuboids, right? Let's assume for the base case, we have these boxes are impossible to put them on top of each other, right? So we have like nothing that we can put on top of another one. So what we can do, we are going to get the height of every single box that we have, and we are going to return the maximum of them. So I'm going to have an array of heights of all the boxes, heights of all the boxes. And because I have sorted them all, so I'm going to get the like the highest number, the biggest number that we can get from the 3 dimensions that we have. And then what I'm going to do, I'm going to have 2 pointers. One pointer is going to point at the current box, and another pointer is going to point at the previous boxes. Right? One pointer is pointing at the current box, another pointer is pointing at the previous boxes. And then I check the condition, if check conditions, and if all the conditions are true, I'm going to update the heights, the dynamic programming list that I have. Otherwise, I do nothing and I go for the second, like for the next box. And finally, I'm going to return the maximum heights, right? So let's see how we can do that. First thing is we are going to sort every single box. So I'm going to say for cuboid, in cuboids, I'm going to do it in place. So I'm going to say cuboid dot sort. So I sort all the boxes. After sorting all the boxes, the second step is I'm going to sort the list of the boxes from the biggest one to the smallest one. How am I going to do that? I'm going to say cuboids, and I'm going to do it in place sort, and then I'm going to say reverse because I want to sort it descendingly, and I'm going to say true. So I have sort all the boxes. After sorting all the boxes, I'm going to do the dynamic programming list. How am I going to do that? So we know the third item here, which is index 0, 1, 2. At index 2, we have the height. So I'm going to say for cuboid at index 2, for cuboid in cuboids. So what I'm going to get the height of all the boxes, and because I have sorted them all, so I'm going to get the biggest number for each box, right? And then what I'm going to do, I'm going to have 2 pointers. For I is going to be my first pointer, which is pointing at the current, which is going to point at the current box. So for I in range, so am I going to start from 0 or am I going to start from another index? For the index 0, in the boxes here, so there is no box previously to compare this box with the previous one, right? So I don't have any boxes at the bottom. So I'm not going to start from index 0, I'm going to start from index 1, cuboids, and I go all the way to the end and I check all the boxes. I'm going to say the current, what do I have here, width, and the current length and the current height is going to be the cuboids at index I, which is the current box. And then for the second pointer, I'm going to have J in range. And what is going to be I? Why I? Because I'm going to, this is going to be an exclusive range. It starts from 0, right? And it goes all the way to I, but it's exclusive, right? So it doesn't compare it with the I index, which is going to be the current box. And then what I'm going to do, I'm going to get the previous width, previous length, and previous height is going to be cuboids at index J. Then what I'm going to do, I'm going to compare them. What is the condition? It should be smaller than or equal, and we should have all these conditions true. So I'm going to check if CW is smaller than or equal PW, and CL is smaller than or equal PL, and CH is smaller than or equal PH. I check the current box with all the previous boxes, and if it is true, so it means I can put this box on top of the previous box, the bottom box, right? So, and then I'm going to update the height that I have. So I'm going to say height is going to be equal the maximum of what? The value that I have in height right now. So the heights at index I that I have right now, or the value that I have from the previous box plus the one that I have, right? And then I'm going to return the maximum, all the heights that I have. So this way, with comparing them all, I'll get the maximum. So we can just code them, but I just remove them, and let's run this. So it says I have a typo here. We should be very careful about the typos. And for qubit in qubits, I'm going to, so it's complaining about this for condition that I have here. So it says for the box that I have in the cuboids list, for the box that I have in cuboids, do I have a typo? Okay. So it seems fine to me. Let me run this again. So it's complaining about the condition that I have here. CW, PW, CLPL, and CHPH is going to be are going to be smaller, and then I'm going to update the height. Oh, I forgot to add the what index I'm updating that height for. So there we go. So the time complexity for this is going to be quadratic because we have two like for loop and we have an inner for loop, and the space complexity is going to be linear because of the height that I have. Thank you.